Thank you very much. I would like to welcome with Hello World. So yeah, I would like to show you my open source process of thinking about writing IoText data protocol. Yeah, let's start. So agenda is not so complicated. I have three, let's say, general positions here about the motivation and showtime. Yeah, so I'm Marcin. My nickname is Bieli on GitHub. As you can see, I have a lot of years in IT, in electronics, automation, multiple big data domains. Currently, I am data solution architect and team leader in Stellantis company. Um, yeah, so I'm using every day Linux kernel with different distributions of Linux. Yep. Every day we have a challenge with my colleagues in my company with 50 petabytes scale data streams. Yeah, my hobby is IoT, embedded systems. I'm researching some IoT protocols, and I have a meetup on meetup.com about IoT hardware and robotics. I'm traveling by electric scooter after the work. My motivations for today presentation is time series data. What it is, if we imagine that we have real-time data from different sensors, different devices, different data sources, this is about it. Yes, so sometimes we need to collect information about temperature, GPS location, any kind of LiDAR or camera events. So it was my motivation to write my own simplistic protocol. Yeah, of course, in case of time series databases, data area or domain, we talk about data in the fly concept. So the issue with that is not so simple. So when data flying, so we have, let's say, per second millions of events. The question is how to check, how to detect any kind of issues or how to debug those kind of data. So there is a traceability concept, this generic concept, how fastly find issues inside data. There is a lot of tools on top of that, but my motivation was I would like to have simple protocol for my own, let's say, home automation, kind of research in case of the serious data sets in data on the fly. Yes, so I try to write something in multiple programming language, but in my motivation there is a important aspect. There is a target solution. Yeah. So Rust, in this standpoint, give me an answer for how to write code in one language for multiple architectures. So in embedded systems, as you can see, there is a lot of possible architectures for building IoT devices. Yeah? Okay, so this talk is about writing some code, failed, test and run, typical dev story. But I would like to have measures for my inventions. So because I started learning Rust almost 2 years ago, and this project, this IoT protocol, is my first, let's say, a learning path. And I would like to have what kind of ecosystem is behind Rust, what kind of library ecosystem is behind Rust, how to write stable but not critical sophisticated code in Rust. And as an IoT enthusiast, I would like to have some fun with writing Rust code. Yeah. There's a showtime. I would like to show you the motivations behind IoText protocol. So I would like to have protocol with human readable, like a JSON, yeah? With simplicity in mind. with easy traceability without special tools. Text-based, easy extensible. Yeah. So if in new version I would like to add new features, it will be possible. For time series, of course, easy to compress, pack any data sets, type of list, and things like that. No, without limit in case of data set, raw or records count. And we have it. There is an open source project you can find here, and there is a first, let's say, iteration written in Python with full specification of protocol. I show you for the moment some basic details. So specification, this is not something fancy or complicated thing. I decided to split data items or fields through a few separators or special characters. And you can see there is a simplistic message. There is a timestamp in Unix with a Unix timestamp with milliseconds. There is a device ID. Oh, there is a device ID and one metric. Yep. So generics here are simple. TRD means timestamp of device name, and M means it is metric. It is something where we would like to inform the receiver that there is a water level, for example. This is an integer and value is 42. Yeah. As I said, we have only 4 special characters. This is easy to learn. Yeah, let's go deeper. Here we can see multiple metrics. So the metrics have their own standard. When we start with them, next you can see pipe, metric name, equal, type, and next special char with value. So from types point of view, we can see signet integers, boolean, signet decimals, 96-bit integers with sign, and text values. Yep. So I would like to show you how it works with simple message on the demo. Give me a second. Hello? All right. Let's imagine it is a client of data from wind turbine. Maybe we can decrease the volume a little bit. Thank you. Yeah, so here you can see the visual representation, a piece of code written in Rust and Riley. And here I have simplistic, let's say, client. This is software which listening on TCP or UDP, I don't remember, probably is the TCP on the port, and we can put the messages. So when okay, that way. Yeah. Okay, you can see here, let's say server, receiver, and here is the client piece of software. So when I using buttons, I have a function to recreate the IoText protocol messages, and this receiver receive and show you the data. Yeah? So this is something fancy, but this is the proof that it works. Yeah? And the message is as simplistic as it is. Yeah? This is one example proof that this library works with the, let's say, message bus, and you can download that and enjoy. I would like to return to the presentation. Okay. So my journey from into Rust, starting with Python inspiration and TikToken library. So I discovered that TikToken open source library have this interesting thing. So this is a Python library, but some code inside. Here you can see there is a Python import and some functions are called. But here inside the repository you can find, sources and of course lib.lib, and there is a Rust code. So this is interesting and very important for OpenAI company piece of software. As you can see, this higher ranked. And here you can see example how we could, if we want, we could implement something faster in Rust and add as a Python project or Python library. When you're using pip install, there is a process of compiling Rust code with bindings. Those bindings are called PyO3. Yeah, so this was my first choice. I put some, code. I created my pull request, but it is a weird piece of code. As you can see, we have multiple bindings, probably here. We need to have some, let's say, reflections, some annotation. We need to have function for transforming data from Rust to Python. Some wrappers are there. And when I starting write my protocol with this solution, I decided, no, I need to stop that. And I need to learn Rust from scratch. Yes, so I put the hand on the keyboard and decide to create a Rust implementation of IoText protocol. So this is the repo. This is pure Rust solution with crate, so you can, use IoText _rs in your project. So when we would like to switch the performance, because if we talk about protocols and any kind of things for transforming data or transmitting data, we need to have some references, yeah? And I show you that what kind of performance it is, comparing to the most popular ones, like AVRO, Protobuf, and JSON, of course. So here is payload, test payload in IoText protocol as a reference. And let's start with JSON. Everyone here knows what is JSON. It is default let's say, standard in web development, in exchanging data. But what is interesting that there is a JSON schema on top of that. So if we would like to have a more clean visualization for our data, we can use JSON schema to define our schema and versions, because in real production systems, the versions change every day or after a deployment. Yeah, there is a this format is human readable. There is a JQ ported through different operating system tool when you can filter records or data in JSON. Very popular, but there is one interesting information. There is resources intensive consuming, especially for CPU and sometimes RAM. If we talk about gigabytes of JSON files or data streams. So in my example, I'm using this kind of payload in JSON to compare with other data or data protocols. Nothing fancy probably for everyone. There is a representation of timestamp, device ID, and some metrics without CRC. So comparing IoText to JSON, okay, let's maybe start. This is comparison made on localhost. So error rate is almost 20%. It's not precise, but some imagination is behind. So as you can see, this IoText protocol instant realization time have similar time with JSON, yeah? But IoText is written in Rust, JSON is written, JSON serialized is written in Rust. Every kind of comparison here was written in Rust. So my assumption, or let's say requirements, was let's start with 10 measures per second for full 24 hours. Yeah? And this kind of payload give us, if you would like to serialize this one-day payload, you can see here with IoText we have 70 seconds, with JSON we have 60. Yeah, this is similar, let's say. Okay, so let's switch to Protobuf. Protobuf. This is originally developed by Google. This is interesting because in Protobuf we have defined strict contract about our data. Yeah, so as you can see, we need to have this proto file, and this is a definition of our package, protocol, messages, and there is much more because we can use this Protobuf to creating our web services, remotely called, and things like that. Yeah. So comparing IoText to Protobuf, we can see a huge difference. Yeah. Why? Okay, so maybe we need to switch to some code. So Protobuf definition, it is like a DSL. Yeah, we can see there is a special dedicated language, domain language. But in build process, this is example of one of the metric collection. There is a building process when some macros in Rust build dedicated let's say generate special model file, and this is a huge file, but there is there we can see here definitions for our resources. Let's say IoText data raw, there is a representation of a message. Yeah, there is an item. Inside item we have possible one of multiple values. Okay, I didn't start with that we have here few fields, or fields are enumerated and one field is repeated. Here it is a matrix. Yeah? So we would like to have multiple metrics per one timestamp for one device. Yeah? All right, so this file is generated. So we have generate, because in Protobuf there is a Protobuf compiler we need to install on our operating system. And Protobuf supports multiple languages, not only Rust. And in this standpoint, we need to import or use some, dedicated, let's say, resources, and we need to define something with that way, because we using special on the compiling time representation of our protocol definition. Yeah. So this is a reason, because this is a binary protocol, strong binary protocol. This is a reason why it is fastest for any kind of text protocol. Yeah. Let's go to the next, maybe. There is AVRO. AVRO is a typical protocol for Apache Hadoop ecosystem or data engineering world. So it is very popular in messaging systems like Apache Kafka, Spark, Pulsar, Flink. So there is a dedicated schema required too. Yeah, so you have definition. For comparison to IoText data, I have the same representation of timestamp, device ID, and the metrics. Yeah. And after running some, maybe not some, maybe 100 iterations of serialization, we can see that here is a text simple protocol with this 70 seconds, and AVRO serialization time, it's 11. Yeah, it's interesting to see this kind of information, because previously for Protobuf, this one day of serialized data, it is almost 200 megabytes, but here in AVRO, in binary format too, we have 164 megabytes. So there is a kind of optimization here. Comparing all protocols on one table, we can see that IoText protocol is not the highest one. But there is a good information because this is simple. So if you have, home automation, your own solutions, you would like to have a fast iteration in your products, probably, maybe it is something for you. Comparing time, because we have almost million records here. Yeah? So this is a representative, let's say, probe. Comparing time, there is not so speedy. As you can see, the Protobuf is the winner. Comparing the payload is few times less comparing to JSON. Yeah, maybe in some solution for you, it will be maybe it will be some kind of alternative for JSON. All right. So what I discovered after this comparison or few checks for Rust for some embedded systems and when I written my protocol for embedded systems, there is a lot of framework, not a lot, excuse me, a few frameworks, but maturity level, I don't know, is enough for production. So there is a lot of blinking, Wi-Fi connection examples. So this is good. But there is an important aspect. So in multiple libraries, you need to have no STD definition instead of STD library definition. Why is it important? Because when I wrote the protocol for, typical machines for Linux, not fancy IoT devices, I discovered when I tried to port to Raspberry Pi Pico that it doesn't work because the memory model, the cargo targets are different. So there is a different situation for allocating memory. There is no, free allocators like instance delete. We need to care about the limits. There is a different implementation for array list or vectors for dedicated for no STD implementation. So all devices in embedded system has memory X definition with internal area. So it is supported by a few Rust frameworks. And in case of porting those library, I discovered the futures are our friends. But when we have one, futures declaration on condition per line is maybe some not clean from software engineering perspective. Yeah. I have a lesson learned here. So my feelings about Rust, as let's say junior in Rust, are very good. Okay, we need to restart the.
So maybe, sorry.
Yep.
Okay, now it's okay, I guess. So maybe we can use this time for a question break.
Of course.
Okay, so here are the questions. The most voted one is when we will have terminal TUI for Windows Turbine.
Yeah, so this is good subject for tonight hackathon to rewrite the TUI. Yeah, it's good idea.
Okay.
We can do that.
Did you compare IoText format with existing one for metrics, like for example StatsD?
No, but it's interesting idea because StatsD it's production grade solution. I have the experience with that, so I can do that.
Is the performance benchmark, what did you use for, in the performance benchmark, what did you use for serializing JSON?
All right, so any kind of library have their own serializer. For example, AVRO have their own serializer, but Protobuf have their own serializer, but in IoText protocol, I've written my own serializer. Yeah, so this is simple answer for that.
And last question for now. Have you done some flame graph profiling to optimize IoText errors?
Yeah, this is what I have in my plans about increasing performance, and I have some ideas how to profile those things, but this is, well, as I said, this is a journey. Yeah, so I need next weeks maybe
Okay.
spend on that.
Thank you. So question break is over, and we have the slides back again. Sorry for troubles.
All right. So this is maybe a message for our newbies in Rust, because my feeling when I create my own library in Rust is very good. It is very good ecosystem. I have experience with multiple languages, yeah. So here I can see that there is a more supportive and informative compilator compiling to Scala, Python, of course, to GCC and G++. There is a mature, stable toolchain and ecosystem, I think. Macros extends our development powers and give us speed up in development, but we need to spend some time how to build macros well and how to use our macros in any kind of targets, because it's not so easy to porting those macros when we allocate some memory or we have dynamically allocated something. There is a very easy step, maybe 2 steps, 3 steps, how to publish to the crate our own library. I think on low-level programming, there is a lot of materials about embedded systems in to ASP32, STM, Raspberry Pi Pico, and NRF. But I think there is a little bit of too less examples or templates how to start with particular platforms. Very good support for my multiple libraries. For example, I used Rylib first time with Rust, and it was very easy to write desktop application for the demo. WebAssembly, it is very interesting output from Rust. I used that solution, this technology. Yeah? So you're writing in Rust and you can see your fancy front end on web browser. Okay, there is a quite nice ecosystem to building web services or services for web development, for any kind of this stuff. Performance, in my opinion, is depend in data engineering especially. It's depend what we comparing, yeah, because some libraries like Apache Spark are designed to parallel computing or distributed computing. But in Rust, there is a space here to write something or porting something to the data engineering ecosystem. I believe it will be in next months, years on market, on open source market. So future flags, very interesting feature. We have flexibility to cross-platform development, and of course there is a quite good and a lot people in open source community. Mixed feelings. This is interesting. In my opinion, Rust is not an easy language. When you are an expert, if you programming language, it's easy. Another aspect of discovery, reflections, kind of definition of software usability tools or libraries are not on mature level. Non-intuitive API in multiple libraries for reflections, but of course I can put my pull request to that. It is good. So STD or not STD. This is a subject when we need to have different mindsets. When we try to port something, or when we try to write something in Rust, it will be good to have understanding of our targets. Yeah, on our target. Yeah, it will be one. Okay, it's easy to choose. We need to review references or dependencies if we're starting for no STD, for example, because this is not easy one, in my opinion, how to write cross-platform solutions. But after few hours, you can easily discover that there is something to do. Okay, so I have a few challenges for my protocol. First, it will be writing a plugin to Grafana ecosystem. Grafana is a visualization tools for any kind of plots, metrics, data streams. This is my first point. Next, it is extends IoText protocol with schema versioning. So there is a pull request. Give me a second. I need to put address them. There is a pull request in this repository. A few pull requests. They are not issue but enhancements about where it is. Schema versioning, schema definition. So not that one. Excuse me. But you need to know that in AVRO there is easy way how to versioning the data protocol. So you have the schema definition and you can use versions. So there is idea behind it in my protocol. Yes, it is here. So maybe I need to zoom out a little bit. So there is a S special, let's say, key, which give us a version, and we can use special patterns to put device names with and mapped with some keys. Yeah, and that way we no need to we no need to rewrite few things. It will be easier probably to use references. Yeah, as you can see here, 02 is a reference to something. Yeah, and there is a space to schema versioning because this is something what give us optimization. Here you can see there is about 54% in optimization comparing to JSON when we talking about this example of versioning idea. Yeah? So there is a lot of possible way how to optimize a protocol. Maybe I need to return to PyO3 and Python and Rust, let's say bindings, to have experience with that. I would like to publish multiple hardware target specific tests or sub-project in examples how to easily use this protocol. And it will be good to find commercial usage. Maybe someone would like to have this kind of stuff in his project. And maybe with Elon we'll be on Mars as a joke. There are a lot of better protocols for rockets. Yep. So that's all from my side. Thank you for watching. As you can see, there is a link to repository. I have a multiple presentations about IoT things in slideshow, excuse me, and you have a contact to me. That's all. Thank you.